In this video, what I want to talk about are a set of rules of substitution that are basically all variations on the same thing. They're actually all derivations from DeMorgan's law. Now, DeMorgan's law is this quite simple rule, and here's the things that are built upon it. Let me start with this. There are three places we could stick a not, or a negation slot. So if I were to write A, I could have arrow and double arrow or XOR. If I had any of those connectives there, and I said A, whatever B, there are three places where I could stick a not. I could stick one here. I'm going to call these, I'm going to call that, I could stick one on the right. I could stick one, and I'll use some, I could stick a knot on the right. I could stick a knot on the left. And the other place I could stick a knot is on the outside the parentheses. And that's the three places I could stick a knot. Now, again, even if it's something more complicated, like A and B, arrow, C, double arrow, D, still, outside, left, right, are the places I could still stick a knot. Okay, that's great. Why do I care about that? Because this knowledge allows us to switch between different kinds of statements. In fact, we can switch between inclusive disjunctions, conjunctions, and arrows anytime we want. And sometimes you want to do that. Sometimes it'll be advantageous to do that. You might be trying to solve for a messy conjunction and realize, okay, I can turn that into an arrow and do an arrow in, and I'm good. I'll do an example of one like that, I think, in one more video. But here's how you do it. It starts with DeMorgan's law. DeMorgan's law says this. Anytime you want, you can switch between an and an inclusive or at any time if you change the symbol from the and to the inclusive or and switch the following negation slots. All of them, outside, left, and right. Excuse me. So let's say I've got A and not B. And I said, turn that into an inclusive disjunction. You can do that with DeMorgan's law, and here's how you do it. First of all, keep the same letters, A, B. Change the symbol that you want it to. We're changing into an inclusive disjunction. And then you've got those three negation slots there. You just flip them in reverse. So is there an outside negated here? Nope. That means when we use DeMorgan's law, we're going to flip that on. Is the left negation slot on? Nope. That means we're going to turn that one on. Is the right negation slot on? Yes, it is. That means we're going to turn it off. That means, using DeMorgan's law on this conjunction, we can get this disjunction. A and not B is the same thing as not A or B. Okay, similarly, now think about this one. I said this one before. Not A and B. Those two things are not compatible. Change it into a disjunction using DeMorgan's law. We'll keep your letters. Change the symbol, and then flip all the slots. The outside is on, we're going to turn it off. The left is off, we're going to turn it on. The right is off, we're going to turn it on. So using DeMorgan's law on line 1 on this one, not A and B, or saying not both A and B is the same thing as saying neither A or not B, or not A or not B. Those things are equivalent. Now this is a rule of substitution. And also, in all my examples I've done so far, I'm going from and to ors. We can also go, we can go from inclusive or to and. So we just flip the slots and change the symbol. Outside gets turned on. Left gets turned off, change the symbol, right gets turned on. How? DeMorgan's law. All you do, if you're switching from and to inclusive or vice versa, is you just change the symbol, make sure you keep the letters, and flip all three negation slots. Whatever you have the opposite of that to do DeMorgan's law, and that is DeMorgan's law. Okay, now also, there are some other things that are derivations from DeMorgan's law, and I haven't seen a lot of this stuff online or in other logic textbooks, but they're the same kind of inferences. You can do the same kind of stuff between different connectives. You want to go from and to arrow or vice versa? You do a very similar process. Let's say we've got an and. Change it into an arrow. So keep the letters, change the symbol. In this case, you don't flip all the negation slots, you just flip the outside and the right. So if I want to change this into an arrow, I'm going to flip the outside and the right. So A and B is the same thing as saying not if this, then not this. Just to make sure it's clear, if we had that assumption or derivation, we get this using what I'm calling this conjunctive implication on line 1. It's actually a derivation from DeMorgan's law. Okay, but if I had an arrow, let's say I had not A, arrow, not B. Actually, let me not do that one. Let's say I had A, arrow, not B. Okay, as an assumption, what could I get? Well, keep the letters, change the symbol, and then all for this one, where you're changing from ands to arrows and vice versa, you flip the outside and the right negation slot. So in this one, outside is off, we're going to turn it on. That's going to activate some parentheses. Right is on, we're going to turn it off. So A, arrow, not B is the same thing as saying not both these things. That's kind of like one I actually did in an earlier video where I said something like, you know, Trump can't both be a Democrat and Republican. Is the same thing as saying, well, if he's a Democrat, then he's not a Republican. Then you can actually, using this move, in this case, conjunctive implication, you can go right back and forth between those things without having to do a larger proof. Then this last one here, disjunctive implication. This one's the simplest one of all. You've got an or statement. You go from or inclusive or does not work with exclusive or. There actually are some individual cases, but these rules don't apply to those. So you can't use them universally the same way. Same thing with DeMorgan's law. DeMorgan's law just allows you to go between conjunction and inclusive or, not exclusive or. Even though there are a couple of exceptions, and I think I'll explain that a little bit later. But just you can't use it as a rule. You got an arrow? What you can do, actually I'm going to start with this one. Actually, I'll start with this one. I'll start with an or statement. All you do is you change the symbol, and just for this one, flipping from inclusive or to arrow, you just flip the left symbol, or just flip the left negation slot, I should say. So in that one, let's say we've got this. We've got A or B, inclusively. Just flip the left, not A, arrow B. How do we do that? Disjunctive implication on line 1. And think about this. You do this a lot colloquially. Clean your room or you're grounded is the same thing as saying, if you do not clean your room, you're grounded. Or unless you clean your room, you're grounded. Those are equivalent expressions here as well. Just a little bit of a disjunctive implication there. Oh, let's do another one. Not A, arrow, not B. We got this as an assumption. Change it into an or statement. All you do is flip the left negation slot. So the outside one's going to stick, the left one's going to change. We're going to change the symbol. The right stays the same because all we change is the left. How do we do that? Disjunctive implication on line 1. So in the subsequent material that you're doing for this course, these rules are going to be invaluable. There will be a lot of times where, again, one like this, you might think, oh, I need to do an arrow in to get this from that. No, you can do these things in one move. Look and see if it's got the same letters and some not similar. Can I convert this? These are conversions. Can I convert whatever premises that I have into something else to make my life easier when I'm solving for these proofs? So I'm going to do some more videos on other kinds of advanced rules a little bit. In short, my next videos will be on some of the more advanced rules that you can incorporate in formal logic.